Hi there, the Math Dog here. This is a video that's the second in a series on solving quadratic equations by completing the square. There's a part 1 video that I recommend you watch first. Then there's also a video I have on just simply completing the square. So the problems in this video are a little more challenging than in part 1. The coefficient of x squared is not going to be 1 in these problems, unlike part 1 where the coefficient of x squared was always 1. So again, before attempting this video, you should be familiar with factoring trinomials, putting radicals in simplest radical form, and how to complete a square. I do highly recommend that you watch my video on how to solve quadratic equations by completing a square part 1 before you watch this one. So please have paper and pencil ready to do the practice problems I give after the examples I go through. So let's get started. Okay, so for review, we're going to look at the steps for finding solutions to a quadratic that's a second-degree polynomial equation. Quadratics are polynomials. Polynomial equations have exponents that are whole numbers like 0, 1, 2, 3. If the highest power variable is to the second power, then it will be a quadratic polynomial equation. So we're going to look at the steps for finding solutions to a quadratic by completing the square. So we're going to take this example problem, x squared plus 6x minus 1 is 2. It's a quadratic because the highest power exponent is 2. That's x to the first. Technically, that's x to the 0, x to 0. So first thing, when you complete the square, is you rearrange the equations so that the x squared and x terms are all by themselves on the left side of the equal sign. The x squared term should precede the x term. So I started with this. In this case, all I'm doing is I'm adding 1 to both sides, so now I have isolated the x squared and x term, and the x squared term should precede the x term. Okay, so we have not done this yet in my previous videos, but the coefficient of the x squared term should be 1. If not, you have to divide every equation and every term in the equation by the coefficient of x squared. And this is what we're going to do in this video shortly. For this equation, the coefficient of x squared already is 1, so you don't need to do this. So step 3 is complete the square on the left side of the equation. You take 1/2 of the coefficient of the x term, so this is what you're really looking at here once you get the x squared isolated like this and have a coefficient of 1. You take half of that coefficient, 6. Half of 6 is 3 in this case. Then you square it, which gives you 9, or 3 squared. So now we add 3 squared, or 9, to both sides of the equation, which will give us x squared plus 6x plus 9, or 3 squared. So now the left side of the equation is now a perfect square trinomial. Okay, that can be factored as a binomial squared. That's why you complete the square to get it to this. So notice the 3 and the 3 squared is what's going to go here. So this is x squared plus 6x plus 9, but factors as a binomial of x plus 3 quantity squared. And then the right side is going to be 12. Notice again, x plus 3 quantity squared is x squared, 3x, 3x, and 9. And if you add the inside, if you add these two diagonal terms, you get the 6x that you started with. So this squared does give you x squared plus 6x plus 9. You can also do it mentally by going, this is x squared, this is 9, double the product of 3x, which is 6x, so it's x squared plus 6x plus 9. So now we have x plus 3 quantity squared equals square root of 12. To undo a square, we take the square root of both sides. Again, when you have an equation, what you do to one side, you must do the other side. So I remove then the square root sign by replacing this with the absolute value of x plus 3. Leave the right side alone right now. And when I remove the absolute value sign, I must put the plus minus here on the right side. So I have x plus 3 equals plus or minus square root of 12. So we took the square root of both sides, and when I took the square root of a square, I replaced that with the x plus the absolute value signs on the left side. And then when I remove the absolute value signs, I must go plus or minus whatever's on the right side. So now I isolate the x on the left side of the equation. So in this case, I subtract 3 from both sides. So get x equals negative 3 plus or minus square root of 12, which is the correct answer. However, you can simplify this particular radical because square root of 12 is square root of 4 times square root of 3, but square root of 4 is 2, so this is 2 square root of 3. So my final answer in simplest radical form is negative 3 plus or minus 2 square root of 3. Alright, so now we're going to solve quadratic equations where the leading coefficient is not 1. So what I'm going to do here is I'm going to divide every term by 2. I could do it a couple ways. One way is I factor out a 2 on the left side. So I get this. Then I divide everything by 2. So I have x squared plus 3x equals negative 2. Well, we're going to get a fraction here because now the second step, remember, is take half of the x term, which is 3 halves, and then you square that, so you get 3 halves quantity squared, which I'm going to leave it like that, but that is 9/4 when you multiply it out. So now on the right side I have x squared plus 3x plus blank equals negative 2 plus blank, because what I do to the right side, left side, I must do to the right side. So I'm going to put in here 3 halves quantity squared. I'll multiply that out in a moment. But this then factors as a binomial squared. This is going to be x plus 3 halves quantity squared. And now I have negative 2 plus 9/4 on the right side. So now we're going to work on the right side a little bit. I need a common, I'm going to put this negative 2 over 1. I need a common denominator of, least common denominator of 4. So I need to multiply this by 4 over 4. So on the right side I have negative 8 plus 9 over 4. I'll leave the left side as is for the moment. So the right side becomes then 1/4. So I have x plus 3 halves quantity squared equals 1/4. So now I take the square root of both sides. Alright, so now I remove, since I'm taking the square root of a square, I remove the absolute value, and remove the square root and square signs. I replace with the absolute value sign. So I have x plus, absolute value of x plus 3 equals square root of 1/4. Okay, I'm going to wait to simplify that. I'll do that in a moment. So now when I remove the absolute value signs, I have x plus 3 halves equals plus or minus the square root of 1/4. So now I am isolating x on the left side, so I subtract 3 halves from both sides. Let's do that. Let's do that a little better. So I'm subtracting 3 halves from both sides. Let's show that like this. So I get x equals negative 3 halves plus or minus square root of 1/4. I like to put the square root term after the other term here. So now we're almost there, but square root of 1/4, again we have that property of radicals that we've talked about in a previous video on simplifying radicals. I can write this as square root of a over square root of b, assuming b is not 0. Okay, because that would be, it can't take division, can't have division by 0. Well, in this case then I can rewrite this as square root of 1 over square root of 4. Square root of 1 is 1, square root of 4 is 2, so this is actually a half. So I end up with x equals negative 3 halves plus or minus 1/2. Now we're still really not done, because we should write both solutions. We should clean that up. That's one of the solutions is negative 3 halves plus a half. The other one is going to be negative 3 halves minus a half. So this is going to be negative 2 over 2, which is negative 1. That's one of my final solutions. And then this is going to be negative 4 over 2, which is negative 2. So my solutions are x equals, and I'm going to put them in brackets here because I have two solutions, negative 2 and negative 1. Again, quadratic equations have two solutions. That's the characteristic of polynomial equations. So if we aren't doing a third degree polynomial equation, but it would have 3 solutions. A fourth degree polynomial equation would have 4 solutions, and a linear equation, which is x to the first, has 1 solution. Okay, so we have x is the set of numbers, x equals -2 and -1. All right, let's look at another example. I don't want a negative sign here, so there's a bunch of ways you could do it. But what I'm going to do is I'm going to multiply everything in this equation by, well, before I do that, you could do this several ways, but what I'm going to do is I am going to first add that 1 to both sides, get rid of that, get it over on the right side. So I have -x squared plus 4x equals 12. Now you could multiply through everything by -1, or you could factor out a -1 like this, and that would be x squared minus 4x equals 12, because -1 times -4x is 4x, negative of -1 times x squared is -x squared. Now divide everything by -1, so I get x squared minus 4x equals -12. Okay, we're actually going to get an imaginary solution to this, so I'm not going to talk about this too much yet, but we cannot have the square root of -1 in the real numbers, because you can't have the square root of a negative, because there's no number times itself that gives you negative real numbers. But mathematicians have defined square root of -1 to be an imaginary number, which we call I. So we're going to have to do that in this problem. And there will be another video that goes into more depth of what we call imaginary and then complex numbers. So to complete the square here, I've got a coefficient of 1 here now, so I have x squared minus 4x plus blank equals -12 plus blank. Well, to complete the square, I'm taking half of -4, which is -2, and I'm squaring -2, which gives me 4. So I am going to add -2 quantity squared to both sides here to complete the square. So this becomes x squared minus 4x. Well, we actually don't have to even write that out. We know this has to be quantity x minus 2 quantity squared. That's why we complete the square, so we can get this, and that's going to equal -12 plus 4. -12 plus 4 is a -8. Okay, so now I take the square root of both sides. So this is what I'm talking about. In the real numbers, square root of -8 doesn't exist, but in the imaginary numbers it does, and we'll deal with that in a moment. So now I've taken the square root of both sides, so this is absolute value of x minus 2 equals the square root of -8. Okay, so now I remove the absolute value sign, I get x minus 2 equals plus or minus square root of -8. Isolate the x on the left side, so now I add 2 to both sides. So I get x equals 2 plus or minus square root of -8. So how do we handle this? Well, we're not going to get into detail yet, but square root of -8, because we defined I to equal square root of -1, I can write square root of -8 as square root of -1 times square root of 8, and square root of -1 is defined to be I, so I have I square root of 8. But square root of 8 can be written as square root of 4 square root of 2, because 4 is a perfect square. So this becomes 2, so I end up with 2 times I square root of 2. So my solution is 2 plus or minus 2I square root of 2. This is called a complex number, because this is what we call the imaginary part, and this is the real part. So without going into, again, a lot of detail, all real numbers are contained in the complex numbers, what we call the complex numbers. So real numbers are actually a subset of the complex numbers. So every number in the universe actually is a complex number. So real plus imaginary make complex. we'll talk more about imaginary numbers later, but that's how we handle this. So this is a non-real solution, and there actually are some applications in, say, electronics and stuff where actually you use imaginary numbers. Okay, let's continue. Alright, so the next problem here, there's many ways I guess you could do this, but I'm going to put the subtracted 2x from both sides first to get the x squared and x term on the same side. So I get 7 equals 5x squared minus 2x. And then I'm just going to swap the left side to the right side and the right side to left side. I can do that. So I have 5x squared minus 2x equals 7. Okay, so then as I said, the next step in completing the square is you need to get that coefficient of x squared to be 1. So on the left side I factor out of 5 like this. I said factor out of 5, so that should be 5 parentheses x squared. Okay, minus then 5 times, so I got a 5 here, I'm going to divide a 5 here, because notice that 5 times 2 is 10 divided by 5 is 2, and this is a negative, so I get the negative 2 that I need here by doing this. Okay, so I go 5 times what is 2? Well, 5 times 2/5 is 2. Okay, so now I have this. Alright, so now the next step is actually what I'm going to do next, instead of so I'm going to divide both sides by 5. Okay, so I get the x squared minus 2/5 x term all by itself, get the coefficient there 1. So now I have x squared minus 2/5 x equals 7/5. So now remember the rule for completing the square. I take the coefficient here, negative 2/5, and I take half of it first. Okay, half of negative 2/5 is negative 2/10, but that's also then negative 1/5, reduces negative 1/5. So half of negative 2/5 is negative 1/5. Then I square that term, which makes 1/25. We'll just make a note of that. So my next step is I fill in the blank. So I have x squared minus 2/5 x plus blank equals 7/5 plus blank, because what I do to one side I have to do to the other side. So now the blank is going to be negative 1/5 quantity squared, which is 1/25. I'm writing it like this because it's easier to see what I have to factor this to. So this has got to be x minus 1/5 quantity squared equals 7/5 plus 1/25. So on the right side now I need a common denominator of 25, because the least common multiple of 5 and 25 is 25. So I need to multiply the top and bottom of 7/5 by 5 over 5. So that's 35 plus 1 over 25 on the right side, and then I haven't done anything to the left side in that step, so I have this. So now this is going to be 36 over 25. We may as well add an extra step and write that. So now I have x minus 1/5 quantity squared equals 36/25. Take the square root of both sides, and I have this now. Well, this is so simple, I'm just going to do it right now. That's square root of square root of 36 over square root of 25. I can write as the square root of 36 over the square root of 25, which is 6/5. Square root of 36 is 6, square root of 25 is 5. So this is 6/5. So now I can remove on the left side, so I'm taking the square root of a square, so that's absolute value of x minus 1/5 equals 6/5. So now, removing the absolute value sign, I go x minus 1/5 is plus or minus 6/5. So to isolate x, now I add 1/5 to both sides. So I get x equals 1/5 plus or minus, let's write that again, plus or minus 6/5. That's not really sufficient for a final answer. So there's two roots here, two solutions, roots, zeros, that's what they're called. So we'll just call it solutions right now. 1/5 plus 6/5 is one solution, that's 7/5. The other solution is 1/5 minus 6/5, which is negative 5/5, which is negative 1. So my final solutions to this problem are, there's two of them, the set of numbers, that's negative 1. So that's going to be negative 1 and positive 7/5, or 1 2/5. So that is our solution to that quadratic equation. Alright, let's do another one. So here I have 2x squared plus 1/4 x equals 1/3. So I need to get the coefficient. So I have the x squared and x on the same side in descending order, so that's good, but I need to factor out a 2 on the left side. So I've got 2 quantity x squared plus, to get 2 times what is 1/4? Well, that has to be 2 times 1/8 x, because 2 times 1/8, 2/8 reduces to 1/4. So 2 times 1/8 x is 1/4 x, and that's going to equal 1/3. So now we're going to divide everything by 2. So I get x squared plus 1/8 x on the left side. Now, how do I handle 1/3 divided by 2? And remember, fraction bar means division. Well, I could write that as 2 over 1. If you remember, when you divide fractions, you multiply by the reciprocal. So that's going to be 1/3. You change the division to multiplication, you multiply by the reciprocal, so that is 1/6. So on the right side I have 1/6. Now I need to complete the square. So I have x squared plus 1/8 x plus blank equals 1/6 plus blank. So now I need to complete the square on 1/8. So I take 1/2 of 1/8, which is 1/16, and then I'm going to square that. Well, 1/16 quantity squared turns out to be 1 over 256. You can check that out if you don't believe me. I'll do it here. 16 times 16 is 256. It's a common number that comes up a lot. You should have it memorized. You should know 13 times 13 is 169, 14 times 14 is 196, 15 times 15 is 225, 16 times 16 is 256. You really need to know that by the time you're in Algebra 1. Okay, so that's 256. Okay, so we're good. But I'm going to write this as 1/16 quantity squared. And I'm going to write this over here also as 1/16 quantity squared. So the left side now will factor to x plus 1/16 quantity squared, and the right side is 1/6 plus 1 over 256. So does 6 go into 256? Let's find out. I don't think it does, so we're going to have to get a common denominator between the two, and it's not going to be 256. So 6 goes into 256 4 times, well, maybe it does, I'm sorry. So that's 24, no it doesn't, because 6 doesn't go into 16 even number of times. It goes in twice, and you're going to get a remainder here. Okay, so this one's a little challenging. So what I'm going to do is I'm going to do a prime factorization here of both numbers. So 6, I've done a video on least common multiples and greatest common factors, and this is how you do a prime factorization. So 6 is 2 times 3. Those are both prime numbers. Now 256 we know is 16 times 16, but that's also 4 times 4. Those are not prime numbers, but 4 is 2 squared, and I have a bunch of those. I have 4 2 squareds. It's a little hard to read that. So I have 4 times 4 times 4, but to break it up into prime numbers, that's going to be 2 to the second times 2 to the second times 2 to the second times 2 to the second. But I've got a total of 8 2's multiplied together, so 256 as a power 2 is 2 to the 8th. This is 2 to the first, so to get the least common denominator using prime factorization, we take the highest power of each factor that we see. So the least common multiple is going to be 2 to the 8th times 3, which is 256 times 3, which is a pretty big number, relatively speaking. So that's 18, carry a 1. 5 times 3 is 15, plus 1 is 16, carry a 1. So 768 turns out to be my least common multiple here. So it's kind of a little crazy, but that's what it's going to be. So on the right here, I've got, I'm sorry, on the left side. So I have x plus 1/16 quantity squared equals 1/6. Okay, now I need to multiply. 6 goes into 6, 7, 68. 6 goes 7 once. 1 times 6 is 6. Subtract, that's 1. Bring down to 6. 6 goes to 16 twice. 2 times 6 is 12. So now I have 4. Bring down the 8. So 6 goes into 48. 8 times 6 is 48. So it's 128. So I need to multiply this by 128 over 128. And then I have plus 1 over 256. 256 goes into our least common multiple 768. I'll write that, least common multiple 768. Goes 3 times. Okay, so this is 128 plus 3 over 768. Now I know you're probably going, oh my gosh, what's going on? Well, you gotta learn to get your hands dirty here sometimes. Real problems are not going to be just little simple ones. So this is some good practice in fractions. Very good practice in fractions. So this is 131 over 768. Okay, so now I have x plus 1/16 quantity squared equals 131 over 768. So now I take the square root of both sides. And I get this. Okay, removing the square root sign, I get absolute value of x plus 1/16 equals square root of 131 over 768. Alright, so now removing that, I get x plus 1/16 equals the square root of 131 over 768. Okay, so now I isolate x, I subtract 1/16 from both sides, and I get x equals, and when I remove the, I forgot to put, this should be plus minus there. So now I'm going to get negative 1/16, so I get x equals negative 1/16 plus or minus the square root of 131 over 768. Okay, well, we can do something with this square root of 131 over 768. Okay, so we can write this as square root of 131 over square root of 768. Well, from the work we did earlier, I can't do anything with square root of 131. That's not, there's no perfect squares that are a factor of 131. But we know that 256 times 3 is 768. And square root of 256 is 16, so I get square root of 131 over 16 square root of 3. But to put this in simplest radical form, then I need to multiply this by square root of 3 over square root of 3, because that'll get rid of the square root of 3 in the denominator. So I'm multiplying by square root of 3 over square root of 3. That becomes 16 times 3, which is 48 in the denominator, and then 131 times 3 is the square root of 393. So it's getting kind of crazy, but we have x equals negative 1/16 plus or minus the square root of 393 over 48. So I can actually write this as one expression, because now I can multiply, I have a least common denominator of 48 here. I can multiply this by 3 over 3, so I get this. So my final answer is going to be x equals negative 3 plus or minus the square root of 393 over 48. Woo. That was a little challenging there, and thing is though, if you can do this, you're really getting pretty good, and that's the idea. You want to be able to do this. Okay, so in some of the higher classes, it may take several pages to answer a question. Okay, but that's what separates. If you can do this, you have a skill set that most people frankly don't have, and if you have skills that most people don't have, that makes you, particularly in mathematics, because the sciences and so forth heavily rely on mathematics, that gives you a heads up on other people and makes you more employable. Anyway, let's move on. So now let's do practice by completing the square. So stop the video and solve this problem by completing the square, and then turn it on and see if you agree with what I get. Alright, so here first thing I'm going to do is get this by itself, so I'm going to add 1 to both sides. So I get 4x squared plus 8x equals 3. So now I'm going to factor out of 4. Get this on the left side. So now completing the square, first of all, let's divide by 4. That's how I've been doing this. I think that's the best way. So get x squared plus 2x plus blank equals 3/4 plus blank. Okay, well, I now take half of 2, because that's what I'm looking at to complete the square now. Half of 2 is 1, and then 1 squared is 1, so I just have to add 1 here and 1 here. That's pretty easy, especially compared to that last question. So now I have x squared. Well, actually now I can factor this as a binomial squared. So I'm taking, this 1 is what I'm taking here, so I'm going to go x plus 1 quantity squared equals 3/4 plus 1. I'm going to write that as 1 over 1. I have a least common denominator here of 4, so I'm going to multiply this by 4 over 4. So I get 3 plus 4 over 4 here, and quantity x plus 1 squared equals this. Well, that's 7/4. So quantity x plus 1 squared equals 7/4. Now you should have taken the square root of both sides. Okay, now to get rid of the, so I'm taking the square root of square, so that becomes absolute value of x plus 1 equals square root of 7/4. Removing the absolute value sign, I get x plus 1 equals plus or minus square root of 7 over 4. Isolate the x by subtracting 1 from both sides, so I get x equals -1 plus or minus the square root of 7 over 4. Square root of 7/4 is pretty easy to put in simplest radical form. Let's do that again. Square root of 7 over 4 can be written as square root of 7 over square root of 4. Square root of 4 is a perfect square, so this is just square root of 7 over 2. So we get -1 plus or minus square root of 7 over 2. But we could actually write this as one big fraction, because I could get a common denominator 2, because -1 is -1 over 1. Multiply that by 2 over 2. Now I have a common denominator 2. So I can write this as one fraction, which is going to be -2 plus or minus square root of 7 over 2. And you need to know how to do this, because on the multiple choice test often you're going to get the answer choice in simplest radical form. So x is the quantity -2 plus or minus square root of 7 all over 2. Okay, next question. Stop the video, solve the problem, and see if you agree with what I get. And then start the video, of course, and see what I did. Alright, so the way I'm going to do this is I'm going to add 10x to both sides first. So now I have 5 equals 2x squared plus 10x. And now I'm going to swap the left and right sides. Can you isolate the x squared and x term by themselves? The coefficient x squared needs to be 1, so I factor out a 2 next. So 2 times 5x is 10x. So I have this. Alright, now I'm going to divide everything by 2, both sides, so I get x squared plus 5x equals 5 halves. Okay, then I'm going to complete the square, so I have plus blank equals 5 halves plus blank. So I need to take now half of that, so half of 5 is 5 halves. Then I'm squaring 5 halves, which is 25/4. So I'm adding 5 halves quantity squared to both sides, which is 25/4. Okay, let's do that. It's a little hard to read that one. Okay, so this is 5 halves quantity squared both sides. So now the left side factors to x plus 5 halves quantity squared. The right side is going to be 5 halves plus 25/4. So let's handle the right side there. So I have a least common denominator of 4, so I need to multiply 5 halves by 2 over 2. So on the right side, and this is going to again be x plus 5 halves quantity squared. Again, copy that down. So that has to equal then 10 plus 25, which is 35 over 4. So now take the square root of both sides. Okay, so removing the square root of the square, I get absolute value of x plus 5 halves equals square root of 35 over 4. Removing the absolute value sign, I get x plus 5 halves equals plus or minus the square root of 35 over 4. So now isolating x, I subtract 5 halves from both sides. So x equals negative 5 halves plus or minus square root of 35 over 4. So notice square root of 35 over 4 can be written as square root of 35 over square root of 4. The square root of 4 is just 2. So this is square root of 35 over 2. So I have negative 5 halves plus or minus square root of 35 over 2. Well, I have a common denominator here of 2. I can just write this as one fraction. Negative 5 plus or minus square root of 35 over 2. And that's two solutions. Negative 5 plus square root of 35 over 2. Negative 5 minus square root of 35 over 2. Okay, stop the video, do this one. I have negative 12x minus x squared equals negative 2. And then when you're done, start the video again. So in this one, I'm just going to, you could factor out a negative 1. I'm just going to multiply everything all the way across the board by negative 1 first. Okay, so that becomes 12x plus x squared equals 2. Now rearrange this to have the leading x squared term precede the x term. So we have this. Now this is pretty easy compared to what we've been doing. So now to complete the square, got to figure out what goes in the blanks. Well, I'm taking half of 12, which is 6. And then I take 6 and I square it. So that's going to be 36. But I'm going to leave it as 6 squared for now, because now this factors as x plus 6 quantity squared equals 2 plus 36. Well, that's 38. I'll leave the left side as is for a moment. Now I take the square root of both sides. Okay, so this then becomes, I'm taking the square root of a square, this becomes the absolute value of x plus 6 equals square root of 38. Removing the absolute value sign, I get x plus 6 equals plus or minus the square root of 38. So then isolating x, I subtract 6 from both sides. So I get x equals negative 6 plus or minus the square root of 38. Okay, well, 30, square root of 38, I can't do anything to it because that's square root of 2 times square root of 19. Those are both prime numbers. They cannot be. There's no perfect squares here. So my final answer is negative 6 plus or minus square root of 38. Okay, this is our last practice problem. So let's see if you can do this one. Okay, so I have 4x squared plus 1/3 x equals negative 1/6. Stop the video and work it out with your pencil and paper and then see if you get what I do. Alright, let's take a look at this. So it's probably going to be a little messy. So what I'm going to do here is I've got the x squared next term on the left side already, but I need to factor out a 4x squared. A 4 out of this right here. So the thing here to challenge is, okay, 4 times what is 1/3 x? Well, that's going to have to be, notice if I multiply by 1/12 x, 4/12 reduces to 1/3, so 4 divided by, so if I end up with, so what if I multiply this together, I get 4 times 1 over 12, which is 1/3. So that's what I need to have here when I factor out the 4. And then this would be negative 1/6. Alright, so now I'm going to divide everything by 4. Okay, so on the left side I have x squared plus 1/12 x. On the right side I have negative 1/6 divided by 4. I'm going to write that as 4 over 1. So remember, your fraction bar means division, so negative 1/6 divided by 4 over 1 is the same as negative 1/6 times 1/4, which is negative 1/24. So this is going to be negative 1/24. Okay? So now to complete the square, I'm taking half of 1/12. Which is 1/24. Then I'm taking 1/24 and squaring it. Okay, 24 times 24 . 16, carry 1, 2 times 4 plus 1 is 9, placeholder 0, 4 times 2 is 8, 2 times 2 is 4, that's 576. So I'm going to now add my blanks. So in the blanks is going to go 1/24 quantity squared. So this factors as x plus 1/24 quantity squared. The right side I have negative 1/24 plus 1/24 squared. Well, 24 times 24 is 576. Okay, but we know that 24 over 24 is 576, so if I multiply negative 1/24 by 24 over 24, a little hard to read there, that's going to be negative 24 plus 1 over 576, which becomes negative 23 over 576. And then we're just going to bring this down. So I'm not changing anything on the left side here. So that's x plus 1/24 squared equals negative 23 over 576. So now we take the square root of both sides. Notice this is an imaginary number. So we'll handle that in a little bit. So I have x, this becomes x plus 1/24, the absolute value of that. That's going to be square root of negative 23 over 576. Okay, removing the absolute value sign, I get x plus 1/24 equals, I'm going to keep it still like negative 23 over 576. So now subtract 1/24 from both sides. I get x equals negative 1/24 right here I should have put plus or minus because I removed the absolute value sign. So this is going to be negative 124 plus or minus square root of negative 23 over 576. Okay, so now here's what I'm going to do. Remember, I defined I to equal the square root of negative 1. So I can rewrite, let's rewrite this square root of negative 23 over 576 can be written as, let's make that a little bigger. So I is square root of negative 1. So square root of negative 23 can be written as, and we're going to write this as square root of negative 23 over square root of 576. The good thing here is we know this, that 576, square root of that is 24, because 24 times 24 is 576. So the bottoms right now is fairly simple. That's going to be 24. The top I can rewrite as square root of negative 1 times square root of 23. But square root of negative 1 is defined to be I. So this is I squared root of 23 over 4. So now in my problem, I have negative 1/24, and that should be 24 here. Negative 1/24 plus or minus I squared root of 23 over 24, but I have a common denominator of 24, so I can finish this out by writing this as negative 1 plus or minus I squared root of 23 over 24. And that is my solution. That's a pretty challenging problem, but if you can do it, you're getting really, really good. So I think it's worth putting a few of those in this video to show you how you can actually,
please give it a thumbs up or a like.
Manipulate fractions
on the YouTube
you
channel.
can do these.
Consider subscribing to my YouTube channel.
And if not, it gives you something to work
Dawg.
towards.
You may
so
share
this
the content
completes
of this
the video.
with
I hope
others.
it
Thank
was
you.
helpful.
Have a good day.
Thank you.